Hello, now let's solve a real world system of equations. This one's about a smoothie shop that sold smoothies and acai bowls. What we're going to do today is use two equations to figure out how many of each they sold. Let's start by reading the problem. And it says a smoothie shop sold 60 items in one day, consisting of smoothies and acai bowls. Smoothies cost $4 each, and acai bowls cost $6 each. The total sales were $300. How many of each did they sell? Well, let's start by defining what each variable means. So let me go ahead and highlight something first. We see that smoothies cost $4 each. But we also see the acai bowls cost $6 each. And we need to figure out how many of each did they sell. That's very important. So that's why I said let's start by defining what each variable means. So for smoothies, we'll say S equals the number of smoothies. The number of smoothies. And then for the bowls, we'll say B equals the number of bowls. Okay. So now we have that. And from the problem, we do know two things. They sold 60 items total, and the total sales were $300. But let's start with them selling 60 total items, and this will become our first equation. So we have S and B, okay? So we'll write smoothies for S plus B for bowls equals 60. Remember, that's the total of items that were sold in one day. Okay, so smoothies plus bowls equals 60. Now for our second equation, we know that the total sales were $300. So that means each smoothie is $4 while each bowl is $6. So we'll write this as this, 4 times S, right? Because the 4 is for $4 for smoothies, plus 6 times B. So $6 for the bowls equals a total of 300. All right, so now let's go ahead and solve by substitution. And from the first equation here, we'll go ahead and solve for S. So I'll write that right over here to the right, solving for S. So we have S plus B equals 60. And since we're solving for S, we're going to subtract the B from both sides. And when we do that, we get S equals 60 minus B. Okay? So that's what S is. Now, what do we do here? Well, what we're going to do is plug that into the second equation, as you can see here. So you can see we have 4 times S, and we found what S is right here is 60 minus B. So let's go ahead and rewrite the second equation, and I will go ahead and write that right over here to the top right. So we have 4 times, and we have 60 minus B for S. So I'll write 60 minus B, and we'll continue writing everything else down. That's plus 6B equals 300. As you can see, we have our typical equation where all we have to do here is distribute and simplify. So let's go ahead and do that. Now we have 4 times 60 equals 240. And then we have 4 times negative b equals negative 4b. Bring everything else down, plus 6b equals 300. Okay, so now we're going to combine like terms. So we have 240 plus 2b equals 300. We're going to solve for b, and we're going to do that by subtracting 240 from both sides of the equation. And notice that we have 2b equals 60. Now we can solve for b by dividing by 2, and we get b equals 30. Okay, so now we know that b equals 30, and so since we know that, we can plug it back into the first equation, which you can see over here. So let's do that. And we have s plus, and b is 30, we found that right up above it, equals 60. Now solving for s, all we have to do is subtract 30 from both sides of the equation here. And we end up with s equals 30, as you can see. Okay, so what does this mean? Well, we found our final answer. S, let me go ahead and box that in. S equals 30 and B equals 30, meaning that the shop sold 30 smoothies and 30 bowls. Okay, and if you want to do a quick check, you can just say, well, 30 smoothies were sold at $4, which equals $120. 30 bowls were sold at $6, so 30 times 6 is 180. And when you add those together, 120 plus 180, that gives you a total sales of 300, which actually checks out. So all in all, systems of equations do let us solve real-world problems where two conditions happen at once, as you've seen here, like total items and total cost. In the next problem, we'll look at a work rate problem where two people or machines work together to finish a job.